Unit 5, practice FRQs. Not really. It doesn't really take you 55 minutes to do these. You should plan generally for about 15 minutes for each of these, and that's like max. Really, you should be able to get these done in 8, about half that time. All right, so let's get started here. For this first FRQ, we're given a function f. We're told that it's continuous on this closed interval, and we know this point and this point. So we know 0, 10, and 10, 9. The function f prime and f double prime have the properties given below. Okay, so remember, these are f prime and f double prime. They are not f. The only thing we know about f are these 2 points right here. Okay, so we have, these are essentially, this essentially is a plus minus graph. It's just in table form. If you want to draw some lines, whatever, you can do it like that. I did it for you right here. What are the x-coordinates of all the local extrema of f on the interval from 0 to 10? So we're going from 0 to 10. It's also right here, 0 to 10. Are they minimum or are they maximum? Okay, local extrema, those are maxes or mins, okay? They're not absolutes. So we got a sign line or a plus minus graph for f prime. When I did it, I just did, 0 to 2, and then to 5, 8, and then 10. So 0, 2, 5, 8, 10. And I put my signs on it. I can see very clearly that we do not have a max or min at these points because the sign is not changing. Here, f is decreasing and then increasing, which means we have a minimum at 8. So that's why I say at x equals 8, there is a minimum because f prime is less than 0, then f prime is greater than 0. This part right here, extremely important. Okay, that's your explaining. Okay, next we got B. It says, what are the x-coordinates of the absolute max and the absolute minimum points of f on the interval from 0 to 10. Now that's different, okay? Now remember, for absolute max and absolute min, you test 2 types of points. You test the critical values and you test the end points, okay? So the CVs and the EPs, you gotta test the endpoints and the critical values. Okay, now, I'm not going to check this critical value or this critical value because the sign, or we're decreasing. That's not going to be a max or min. Okay, so I'm not checking those ones. I'm only going to check 8, and then I'm going to check 0, and then I'm going to check 10. So let's think about that for a second. If I scroll up here a little bit, we see at 0 we're given the value 10. At 10, we're given the value of 9, and these are endpoints. The only thing we don't know is what the value is at 8. Now, we do know that 8 is a local minimum, and we figured that out in the first one. So the question is it the lowest? We know it's definitely not going to be in competition for the maximum value because it's a local minimum. Okay, so either 10 or 9 is our maximum value, and obviously it's 10. So we have a max at 0, and then we are decreasing until we get to 8, and then we increase to go to 10, which is 9. But we know for sure that 8 is lower than 9. So 8 must be where our absolute max is, because 8 is definitely smaller than the value of 10 at 0, right? F of 0 is 10, which is why I wrote x equals 0 is where the absolute max is, and x equals 8 is where the absolute minimum is. Now, it doesn't say why here on this problem, but here, what's this extra stuff I wrote? Because the graph decreases until x equals 8, and at the end of the only increase, wow, someone's got to work on this guy's English. We only make it up to 9 at 10. So, but anyways, we know for sure that this is 0 is where the max is and 8 is where the min is. And I have an explanation here that has bad English. All right, what are the x-coordinates of all the points of inflection of the graph of f? Now, when we're looking at points of inflection, remember, we're looking for where the sign changes. Okay, this says justify your answer. That's why you don't see just x equals 2 and x equals 5. If we look up here at the table, we go from positive to negative, so therefore 2 checks out. For 5, we go from negative to positive, so 5 checks out. For 8, we go from positive to positive, so 8 is not an inflection point. Okay, our only 2 inflection points are at 2 and 5. And why? Well, here's where you have to state that the sign is changing. But notice I'm saying f double prime is greater than 0, then f double prime is less than 0. You got to say that. You got to say the double prime because, you know, there's signs for f prime and there's signs for f even. We need to make sure that our grader knows that we understand it's about the double prime, the second derivative. All right. On the axis provided, sketch a graph that satisfies the given properties of f. Okay, so if you guys go back and look at your KISS notes, there's 4 different types of curves, okay? Concave down and then concave down. But one is increasing and one is decreasing. Here's concave up, increasing, and here's concave down, increasing. I'm sorry, here is concave up decreasing. Okay, so we have all these types of curves, and you figure those out by using the double signs. Okay, the first sign is going to be your derivative, your f prime sign, and this is going to be your second derivative, your f double prime sign. And so what I did is at every x value that's listed in the table, I draw these dotted lines just to kind of help me know where to start changing my curve. Now we do know 2 points. We know the first point at 0, remember f of 0 equals 10. And we know the last point, which is f of 10 equals 9. Okay, so that's that point right there. We know those points. And so if I were doing this from scratch, I would start at these points. And then obeying my signs, my double signs, I see for this first curve, I'm decreasing and then concave up. So I'm going to put a point right here because I know I'm decreasing and then concaving up. So I just got to make sure I'm curving up. Make sure that when you hit the 2, that you're obeying what the slope says it is. If I scroll back up and look at what the slope is at 2, it says that we're 0. Okay? We got to obey our slopes. All right. Now, another way to do it is by looking only at the first signs. So if I look at decreasing, 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 then increasing, I know from this point I'm decreasing, so I draw a point smaller or lower than that. And then I'm decreasing in, so I draw a point lower than that. And I'm decreasing again, so I draw a point lower than that. And then obviously we're decreasing because this is our last point. Now, some of you guys might be bothered with where I choose to put these points. It doesn't matter. It doesn't matter. Just as long as you're able to have the curves to show that you understand what those curves mean.